Asteroids, those mysterious space rocks wandering through the vastness of our solar system, have long fascinated humanity. Occasionally, they grab our attention with their potential to cross paths with Earth. Such is the case with a recent discovery of a new asteroid traveling in the shadow of Apophis, one of the most infamous space objects ever observed. With a startlingly specific 1 in 83 chance of hitting Earth, this asteroid has reignited discussions about planetary defense and near-Earth object, NEO, tracking. Let's explore what this discovery means, why it's significant, and how scientists are preparing for such cosmic threats. Near-Earth objects, NEOs, are asteroids or comets whose orbits bring them into the vicinity of Earth, posing potential risks to our planet. Although most NEOs are harmless, their proximity invites careful monitoring. What makes asteroids especially concerning is their unpredictability. Slight orbital changes can bring them closer to us than initially expected. The impacts of these space rocks range from harmless atmospheric disintegration to catastrophic planetary effects depending on their size, speed, and angle of entry. Apophis, discovered in 2004, became a household name for space enthusiasts due to its once feared collision risk. For several years, scientists calculated a slim chance that it would impact Earth in 2029. Subsequent refinements in its orbital data ruled out this threat. However, its relatively close pass, estimated to approach within 31,000 kilometers of Earth, has remained an object of fascination. Now, a new asteroid identified in close proximity to Apophis has reignited planetary defense discussions. In a recent breakthrough, astronomers identified an asteroid orbiting in close alignment with Apophis. Smaller in size yet no less significant, this rock is traveling as though it were keeping pace with the Doomsday asteroid. What's drawing attention is not just its trajectory but also the calculated 1 in 83 chance that it could impact Earth. This new object is a stark reminder of how cosmic phenomena can often remain undetected until they are unexpectedly spotted. It also raises questions about whether the asteroid's orbit is influenced by Apophis' own gravitational path or whether this alignment is coincidental. Either way, the discovery underscores the importance of advancing tracking technology to stay one step ahead of potential threats. When you hear 1 in 83 chance of impact, your first thought might be to dismiss it as unlikely. After all, statistically, that means there's an over 98% chance the asteroid will miss us. However, in the realm of space science, any non-zero probability warrants close attention. A 1 in 83 chance translates to 1.2%, which might seem small but is significant enough to draw global focus. To put that in perspective, most NEOs observed by scientists have impact probabilities closer to 1 in a million or less. A 1.2% chance marks this asteroid as requiring careful study. Tracking and refining these early estimates is crucial, as even slight variations in an asteroid's course can drastically change its odds of hitting Earth. Asteroids like this newly detected object and Apophis operate under the complex laws of celestial mechanics. Their paths are determined by a mix of gravitational forces, solar winds, and interactions with other celestial bodies. The fact that this new asteroid follows Apophis' orbital trail raises fascinating questions about why and how it's traveling in close alignment. Some scientists speculate that the gravitational field of Apophis could have had an impact on its followers' trajectory. Alternatively, their proximity may be a coincidence, suggesting they may originate from the same asteroid cluster or have undergone similar orbital disruptions. Understanding these dynamics will allow scientists to predict future behavior, crucial for estimating any potential collision. Monitoring asteroids like these is no easy task. It requires a combination of advanced telescopes, radar systems, and orbital modeling. Ground-based observatories and space agencies like NASA and the European Space Agency, ESA, are at the forefront of this effort. They meticulously scan the night sky for NEOs, observing their speed, size, and trajectory. When an asteroid is first detected, scientists simulate potential orbits based on its velocity and current path. Over time, more data helps refine these models, often ruling out impacts entirely. In the case of this new asteroid, researchers will continue to observe it to narrow down its trajectory and verify its potential for impact in the coming decades. Collaboration is key in the field of asteroid monitoring. Governments, universities, and private space companies all contribute to the global effort to monitor the skies. For instance, NASA's Planetary Defense Coordination Office serves as the primary agency for spotting potential Earthbound objects and working on possible deflection solutions. The potential consequences of an asteroid impact depend heavily on its size, speed, and entry angle. While Apophis is large enough to cause widespread devastation in the event of an impact, this newly discovered asteroid is reportedly smaller. Nonetheless, even a small asteroid can cause serious damage depending on where it lands. The infamous Tunguska event of 1908, for instance, was caused by an object roughly 50 to 60 meters in diameter, a size not too far off from many monitored NEOs. The resulting explosion flattened over 2,000 square kilometers of forest in Siberia. In contrast, larger impacts can have consequences on a global scale, threatening life as we know it. Should this asteroid remain on its current path, scientists will continue refining impact potential and identifying potential risks early enough to act. Preventing asteroid impacts has gone from science fiction to a legitimate scientific endeavor. Advances in planetary defense systems are being developed to mitigate risks from NEOs. The recent NASA DART, Double Asteroid Redirection Test, mission effectively demonstrated our ability to alter the trajectory of an asteroid by crashing a spacecraft into it. This was a remarkable proof of concept that we can deflect celestial bodies if we have sufficient warning. Such missions would depend on early detection, making tracking systems vital. Other proposed ideas include using gravitational tractors, nuclear deflection strategies, or leveraging solar sails to slightly nudge an asteroid's path away from Earth over time. For space enthusiasts, every asteroid discovery is a reminder of our planet's fragile place in the cosmos. These celestial wanderers offer a glimpse into the mechanics of the solar system, and the challenges of tracking them fuel scientific innovation. The new asteroid trailing apophis not only excites scientists but also captures public imagination, raising awareness of space science and planetary defense efforts. It's worth noting that amateur astronomers and citizen scientists also contribute to asteroid discovery, fueling collaborations between professionals and enthusiasts. The vastness of space offers endless opportunities for everyone fascinated by it to contribute to its exploration. The discovery of this new asteroid is a significant milestone in the field of asteroid tracking and planetary defense. While its 1 in 83 probability of Earth impact is far from a certainty, it is enough to warrant close observation and ongoing research. The scientific community is better equipped than ever to track and mitigate such risks, thanks to advancements in technology and growing international cooperation. For now, the asteroid silently follows Apophis through the cosmos, offering us both a challenge and an opportunity to understand the celestial dynamics that govern our solar system. This discovery reinforces that even in an age of advanced technology, the universe still holds surprises, and our vigilance can help turn these cosmic events into breakthroughs in our understanding of the final frontier. For enthusiasts of the sky above, this new find is yet another reminder that space remains a limitless source of wonder and discovery.